Hello everyone, welcome to the stream. YouTube's working now too. Hello Dutch, hello Fu, hello Christian, and hello lurkers. Here we are, punctual or what? um, so, last time we were talking about a lot of cool stuff, and a foo, thank you very much. It's starting with super sticker. The icon is matching with the sound that we had on chat. Thank you very much. I will put it in the font, the excavator font. Let's see what the state is. 3,240, only 2k more. That will be probably sellout money then, to get the excavator ready for spring. Now we have like melting, snow is melted today. We have like really muddy weather. 20,000, this is a lot. This is like 4 euros 30. So unfortunately, or let's say it like that. Hey Yumbo, hey Sonic. I will share the status, order status. The manufacturing time supposedly be like 5 days. Wait, let me check if it's not spoiling any address. No, it's not. Okay, here we go. So another one. Foo, thank you very much. And now we are at 40,000. Nice. Hey, smart apps. Hey, Jussie Harry. So, it took them only, the manufacturing took them, wait, is this tracking? Okay, so from order submitted, here, order submitted was 4th of January. They were finished manufacturing completed production here. Okay, it took them 2 days instead of 5. That is cool. And it shipped, but unfortunately, Leipzig is so slow. It was there in Leipzig, like customs in Leipzig. You see, like China was processed within like 2 days. Hong Kong, Bahrain, 9th of January. That was like, and then Leipzig, it was of course stuck in the customs, and Leipzig. And we scroll. Okay, now it's in Cologne, and then it's still in Leipzig. I don't know why. It's like 3 days later, still in Leipzig. Custom cleared 4 days later. This is always okay. Leipzig 5 days later, and now it's in Cologne, and I got actually a tracking number from DHL, so it will arrive on Friday, but I'm not here to stream on weekends to assemble it with you. So storage delay, yeah. Shipping wasn't expensive, but yeah, unfortunately it didn't arrive today. If it was like processed 1 or 2 days quicker in Leipzig, then we would have an. What? Phew, you made a USB MIDI? Did you code the stack? the USB stack for that? Oh yeah, my on-screen chat. Yeah, thank you. Yeah, I have to like poke it. Interact. Let me. Oh no. I need to reload it and poke it with, I think, interact. Damn it. Here. Interact. Let's see. My good night message. Here we go. Existing USB CDC implementation. Oh yeah, I must admit the CDC implementation of the 35 is quite good. I used it as well. Let me think about it. Yes, but I didn't know that you can do that. That's really amazing. Can you drop the link? Chat is working. Fu, can you drop the link in the chat? We will check it out. Hey, the Shipu. Oh, I teased you with the title. It's not only like casual. Okay, so this will be the topic of next week's stream. The blade, the next ultra cluster part. No named cat. Why can't you just put? Yeah. I always like to wait. Eh? No, that's Arduino here. No. Oh damn it. Okay, let me search it here. Not repo. Here. Am I following you? No named cat. Am I following you? Where's? Huh? Why can't I see? Oh yeah, here, follow. I need to start following interesting coders. Oh wait, that's the log commits. Okay. AI. What is this USB icon? This is ChatGPT. This is not Gemini. Is it? Did you use Gemini or ChatGPT? Because that messed up USB logo. It's Gemini. Okay. It looks like a mixture of like a USB. Comprehensive and efficient. Van Ooyen technische Informatia Voti. Message type. Oh yeah, okay. Pitch band. Did you implement pitch band as well? Everything is implemented. I mean, if you do MIDI data, okay, you have like just an example, or do you have like a callback for each of the messages? Are you handling system messages? Oh yeah, system messages. That's tough because system messages have like this special format, and if you receive system messages, everything will break. But I mean, it's not like you're receiving the data from another device. You're receiving from the PC. You can filter that. Sending me the data. Yeah. Ah, cool. Send. That's cool. Did you do like a PWM or something? Example. Hey Johnny. Send packet. Oh, poly pressure, nice. Could be sysx or standard 1 byte system comment. Are you processing it already? No. Oh, that's cool. Okay. Oh yeah, here are the examples. I missed that. Pitch bend after touch. Wow, that's cool. Drum controller. Oh, that's actually really cool. Are you using polling, or do you have like a interrupt, pin interrupt or something for that? Buttons, index, last state, yeah. Switch change due to noise or oh yeah, so you have debouncing here. That's really cool. It's really I love the chip, and I love MIDI. Hey Alcon. So Andy, I was asking myself if it's Alcon, like the one stands for an L or an I, because it only makes sense that it's an L, but usually the one stands for an I in lead speak. I was recording the testimony for, not spoiling anything, for the winners of the demo scene competition. Backwards, no. Oh, it's an I. Are you from Finland? Or are you not from Finland because it's backwards? Wisconsin, okay. In high school, so sad. Yeah, the Europeans are quite privileged regarding to demo scene. I looked into your code again for the donut code, and the write-up. That's why I sent you the issue, because your homepage wasn't linked anywhere, or at least I wasn't able to find it in the code or in what was displayed on the tiny tape out thing. So people don't know what we are talking about. It's about tiny. Let me. Where is it? Entries. Here. Okay, so Andy did tiny tape out, and we are talking about this one. And yeah, we can watch it though. So you see what's possible on 4 tiles. Wait. Here. So it's a ray marching donut with shading, and it's quite interesting the write up on. I glanced over the code before because I didn't have time. We're doing it on stream and so on, and it's quite a lot of entries. but I went through your explanation, since you pointed out that you have like the write up on everything on your homepage. And yeah, actually it's quite interesting and challenging, because wait, is it? No, that's not the one. Wait. Yeah, here. Tape. Okay. Yeah, that's to read that. I only can recommend to read the article, because the codex. Okay, I was wondering how you managed to do like do it without the multiplication, but in the end it made sense. It's just a shift, like an approximated multiplication, and since you're stepping anyways, it will approximate like the right distance in the end. So like the error is shrinking all the time. So that makes sense. But the interesting part is actually that you did the rotation while did the rotation for the light vector or the view vector while stepping by calculating the length. That was cool. That was quite interesting. Also, what the factor here. Oh. The like to consider that factor here. That's so cool. That's like the MSB. The interesting part is, I don't know I don't know if you're like familiar with assembly much, but finding like the first one from the front is this like an uh, an important opcode for transforming integers to floating points. And I had to do with that. There is like for the RISC-V cluster that I made, a small one, which also has array marching. I needed to transform, like also calculate the square root reciprocal and so on, and it doesn't have even a multiplier. So like there is this, I don't know what the name is of the opcode, but there is like a single opcode that can find like the first one to be able to shift the mantissa into place. And that was missing in the revision of in the version of the kernel, or in not ALU. Let me check that. RISC-V. I struggle with talking today. It will be a hard stream. Tough to listen to. Okay, let me show you. Okay, so actually, where is it? Bit manipulation. So you need, like in RISC-V, you need the bitmap manipulation extension to be able to find the first. There is like an implementation for finding the first one, which is quite cool. So actually, if you want to implement exactly the same donut rendering on like the 10-cent RISC MCUs, you need to pick the right one, and for it to have the hardware support, let me check. Sheets. Let me find the right one. Ultra cluster. Okay, so I went through all the cores for my supercluster, and if we zoom in on that, I used the V3. AJ, I'm not an engineer. I'm a software engineer. So this one only has the Queenie key V2A, and the V2A has only like the EC, so compressed opcodes. What is E again? Let me check that. What was E? Is there anything? E. I don't know. Wait. Oh no, that's E. Okay, base integer instruction set. Here. No, I'm not. I'm pretending to be an electrical engineer. Hey, Jody. Hope you're feeling better today. So no, I'm not doing the similar trick. I'm actually converting. I'm using. I tried. I did even simulations how to calculate like the square root reciprocal correctly, because I have like a little bit more. I don't know if I could approximate like you did, because I have like several reflections and so on. The calculations are quite precise. So I'm actually converting to float at some point. I did some tests with Cordix, and I did different multiplications, but I had like huge errors in when the angles were quite shallow. So there is where the errors happen, especially on reflection vectors. So I finally committed to using Carmack's fast square root implementation, and I did the step of converting the fixed point vectors to floats as an intermediate step, which is really stupid. But I would love to see test your implementation, like the approximation on 10 quantized engine. So okay, so here this is the MCU that I used before, and now the new cluster is either one that's not shown here yet, or the 570, which is a completely different core, in some ways better, in some ways worse. So when I did like this, 570 here, it has like the V3C core, and the V3C core is way more potent because it has like multiplication, and it has also bit operations, and bit operations have the let me check that, because it says like here count leading zero instruction. This is the one that we are talking. So this is you will test your codec, Rohan. What? Lumberjack. What did you do with Cortex? Like on tiny tape out as well? So actually, even though we don't have an FPU, even the change from the core to have a multiplication and bit operations will speed up things so much. Like, I don't know, this will be great. We should really try to compile it, compile the ray marcher to and run it on the better cores. ROMless codec on TT Sky. Do you have a link? Go on. Anyways, this is cool. We can do fixed point way faster, the conversion to float, if we even need float, because I can even multiply. Oh wait, Rohan, sorry, I give you the moderator rights to drop the link. Here, you can drop the link. Game engine on the... Yes, I watched the video as well. The guy who has like the Boolean logic, but he left out a thing. There was one issue with what he was with his engine that he skipped over, and I was wondering how he solved that. I forgot the details, but it's a quite interesting thing. It was like he said it was his first video, and the engine actually looked nice. Atlas tile location. Maybe we can watch it, but I don't want to get flagged. I don't care. Let me check that. I have it in my history somewhere. It was one of the last videos that I watched. And commentary. Let's do some commentary here. Where is it? Oh yeah, I'm on the wrong account here. This is the right one. No, it's alright, it's alright, it's alright. We will do nice stuff today. I will show you. So, we have to wait for Thomas. Since, okay, I will just say what we will do later, but since we are still on ray marching, you remember this part? Thomas asked me for the design files, and he basically found my error there. It wasn't the crystal, it wasn't anything like that. I was missing, where maybe I have the datasheet open still. Yes, I missed one part. It wasn't mentioned in the design reference document, but it's mentioned in the deep annals of of the datasheet. Basically, I have like an external voltage regulator for the core voltage, and I supply the core voltage, but you still need to hook up the internal step-down converter like in a specific way for the device to boot. And then you have like to use a register to turn off the regulator. And without that, it wouldn't work. So I show you, I just didn't hook it up at all, and that's why I didn't boot. And there is one, where is it? Power supplies, power manage, core voltage regulator. Here it is. And this is what here, wait, this is the normal mode. Here. With on-chip regulator disabled. So this is how you have to hook it up. This is so stupid. So you need to like have, I tested different ways. So feedback needs to be ground. Reg in, V in is 3.3 volts, and you need the ground and a VDD. And I didn't have that, but it's an easy fix. I can show you what I did. Here I did it with one core, and spoiler alert, it works. It boots up. So Thomas found actually the issue. We turn on the camera so we can look at the microscope. Bup, bup, bup. Yeah, here you are. This is my botch. Yeah, I needed to like open a little bit of the solder mask and bridge the VCC to the next cap. And yeah, I show you how that works. I bought new USB cables so we don't fail. I keep press boot and then connect. Boop, boop, boop. Here you go. Look at that. Doo doo doo. Yeah. Yeah, it's working. Everything is working. Easy, huh? We can run something on that later. So easy fix. I updated the schematics and the PCB. Hey TMK. It's just working. So my design wasn't very much off. I just need to bodge it. It's a tough one because QFN bodging isn't as easy with a 0.6 millimeter pin pitch. Anyways, all right. So we wanted to check out the shortly. Where is it? Can't be that long ago. Why isn't it showing up here? Huh? Okay, let me search it. I watched it on the TV. I don't know if it didn't. It has to be here. You found it? Oh, here. Here it is. I found it. Okay. Okay. Okay, there is one that was Ray marching. Okay, wait, it was caching the distance. Okay, that was that. Oh yeah, the issue that I was wondering about. He uses an atlas for the grid. So as sparsely, I just give you a summary. So he basically approximates like with trilinear interpolation, approximates the distance to the next, like in one cell and like in the grid to speed up things. And since he can like subdivide the whole world into grid and fill it like all the grids and update them on the fly. He uses a sparse grid, which like only the cells that are affected or are close to a surface are populated, and he then uses basically an atlas, like a lookup, where he stores the data. So wait, here it is. Yeah, this is basically how he does it. But there is one thing that he didn't say is how when he changes, updates the atlas, he said he only updates the cells that changed, but then he has some kind of heap management, because at some point if he fills up his whole like space for the atlas, he deletes old cells that are not used anymore and puts new in. How does he does he have a list of the cells that are unused so he can refill them, or how is that done? He just skipped over that step. That what I was wondering about. I don't know if any one of you watched that and looked into the details, but yeah, it's quite an interesting approach. He didn't mention like octrees, which would also be a way, but I think a grid is a nice solution as well. Not sure though if like a double lookup with random access is like the best performance, but it looks alright. So if it works, it works. So usually, like if you have, I don't know how the cache now works with the modern graphics card, but when back in my time, which is like when I did volume marchers and whatnot for medical, it was always an issue, like the angle of viewing, like the view angle of the volume that was rendered was like the performance was dependent on the view angle, because like the path of each ray was traversing through the volume in a different way, and then you had like a lot of cache misses, so you don't access all the memory as in the same speed. If you have like a cache line and you traverse through the cache line and don't need like to fetch memory to a pixel shader, that's much more performant. And using an atlas, you have most probably always a cache miss, more or less, because like it's like randomly dispersed along the atlas. So the lookup for the grid is probably performant, but then the lookup for the atlas is less performant. I don't know if there is like if there is an issue with that nowadays, but that was one thing that I was wondering about. But really cool engine. I hope he can finish to make an actual game with that. All right, but that's on that. We will do this thing here. I have like 3 more. I lost one. Somewhere on my desk is another one that we tried to botch with. Oh, here it is. No, that's not that one. Oh yeah, it is. You remember that from another stream? This is the first one that we tried to, because I thought it's the crystal and it wasn't the crystal. So we removed the crystal and abused it a lot. Bridging the USB as well, everything. I don't know if I can revert all the changes that I did to this one. It's maybe an artifact from the past, and we will just proceed with that one here. Oh, looky, here we go. And by the way, I removed this crystal. It's optional, the crystal for the USB hub. And we need to do the fixes here. We load KiCad and we continue. For very difficult bodges, you can order a tiny FPC board from Oshpark. Makes it easier. What is FPC? What is an FPC board? FPC. Ah. PCBs, FPGA fabric. Yeah. CPLDs. Oh. Oh, I see. Yeah, or just a flat flex cable that I should even have like flat flex cable. You can just solder to the edge of that. Let me check if I have them here. No, I don't think it's here. Yeah, but we can just use any flat flex cable for that, and just if it's like, no, they all end. But you can just cut it with scissors. If we look at that, that's if you have like the, okay, this is just a random one. But if we take one, let me yeah, like that one, and you cut it here, and it has the right pin pitch or whatever. Maybe we should order something like that. Make one, order it with the different pin pitches, and then easily sortable. Hey, I'm aboard. Ah. Now you know what? Last time, who mentioned like FPGAs again? Last time we had, where is it? Here. This one here. I'm hooked, people. I'm hooked. We should maybe use that for managing the cluster. What do you think? Should I order some of those? Is this SciPete directly? Who's the seller here? Foo! Which one do you have? You have all of them? FPAA. What is an FPAA? Field Programmable Analog Array. Analog Array. Ooh. So it's basically like a breadboard or what? With where you can put resistors and capacitors or what? Ah, you have the 9K. Yeah, 9K. The 20K is way better than the 9K. 20K can also do sound. FPGA. Kaminsen. Ray tracing, yeah. Yeah. If they get a little bit cheaper, we can do like an analog ray tracing board. We only need like multiplication. Not even that, it seems. Imagine that. That's one of the last dreams that. Oh, yeah, you're Oleg. You need to change your name. No. Oh, you. It's weird. It shows only like the handle. What is this? Let me check that. Software defined analog. Yeah, okay, doesn't say much. Okay, let's check that one. But why is it so expensive? Is it made of pure gold? Does it have DDR5 RAM? Ah, right. Okika devices. Jiki. Okay. Okay. Floating gate FPGA now commercially available. All right. Winter's over now. We had like 9 degrees today. It's coming back probably on Saturday, but now it's quite warm and everything is wet. Snow is melting. White theme? How do I switch the theme here on Google? Ah, my eyes are burning. Anyways, let's fix our board. Oh wait. Back to winter. I'm a Boyd. Uh-oh. Okay. I need to check. Wait, here. I fixed that. Ah! Oop. No, that's the wrong one. Ha! This is what I ordered. This is what we do next time. It keeps giving us freedom. Oh, interesting. Does it have Git integrated? That's weird. I never saw the icons here. Okay. It's probably showing that because it's on Git checked in. Alright, okay, let's fix it. Whoop! And go top layer here. Ah, I can't see anything. Ah, let's remove everything here. Maybe even courtyards, silks. Okay, so I fixed this part already. Now next one is down here. So we need to, oh, this is new. So we need to get the first one, and the fourth one needs to go there. Damn it, I don't know the previous configuration. Let me check in the schematic. So I didn't hook it up to anything before. Now it's, here. Sorry. Oh. Come on. Oh, we actually need 6, 9, and an FB, and 4, 7, and 50. 4, 7, and 50. 4, 7, and 50. Okay, so we need to do this here to VCC and this here to ground. That's what we need to change. That was here. So we need to do it here as well. Ground. Oh yeah, Okika, that's what Sonic mentioned. Maybe they can lend a development board to someone. All right. What? Older ones are only cheap? Wait. Okay. You really want to distract me today. Look at that. That looks cool. Okay. Switch capacitor technology for efficient multi-channel analog signal processing, configurable analog blocks per chip, rapid analog prototyping, totaling 8 core amplifiers plus 7 input-output amplifiers. Pre-built library of verified analog circuit cores, fast design cycles. Okay. 8 configurable analog, 8 core, 7 input output. Wait, this is flex SOC FPAA large. Here you when resize that so it will be better shown on your screen. 51. Yeah, you can't do a ray trace and 51 analog gates. You know what's easier than that? Here, there is no log. No. There is like analog electronics math functions here. Schmidt-Trigger, adder, subtractor, differential amplifier. Wait, so no. There was, I found once a list. Yeah. What we square root? Okay, square root is basically, I mean, you always, square root reciprocal. Damn it, where is it? Op-amp integrator? No. Analog. Okay, there's a lot of YouTube videos. I think it was even Wikipedia. There's like a on one of the pages there were example circuits. There was a black magic op-amp integrator. Ideal circuit. No, I can't find it. Diode. So what the idea would be, if you have, let's assume we have a set of mathematical operations that we can implement with an analog circuit, like yeah, wait, this is, but where is the other one? I mean, logarithmic. Though I found once a page. What is the analog thing, Sonic? Since, I mean, if you're in the hundreds of euros for a testing board, okay, you can reconfigure it. That's a benefit. But if you have dialed it in, oh, okay, it's basically, yeah, you can like a Eurorack synth. You can plug it in. Cool. It doesn't look like it's Eurorack. It's like a random. That's cool. Yeah, but what I wanted to say, there is like an implementation, op-amp implementation for each of the mathematical functions. The issue is with vectors that we would need somehow to we can't have large values, like we can't have 1000 volts or whatever for a really long vector. Or yeah, but foo, it doesn't matter if you have drift or whatever. If we do ray marching, you can see it with Andy's donut implementation. He doesn't even like use proper multiplication. He just shifts by the highest significant bit, and that's all. Like the next step brings it closer again. So you just always, you jump like the length that you calculated, more or less. If you jump shorter, it doesn't matter. You have just a few more iterations. Yeah, that's what I would think, Sonic. But how do we solve mantissa precisely? I mean, if you have like if the exponent is like 1, 2, 3, it needs to be really precise. Otherwise, you have like a magnitude higher value. So usually you need like in the lower values you need like a higher like a super high precision, and it doesn't matter in the higher values. So maybe we could use like an extra exponent, but we need to use it like in a logarithmic way or something to, yeah, that would be a solution. But once that is figured out, let's assume we have digital exponent. Oh, interesting. Hybrid solution. In the end, we have like analog voltages between 0 and 1 for the color components. So in some way, the exponents die at some point. They either we have like a miss if low power. It's infinitely fast if you have, oh yeah, digital logic isn't infinitely fast. Only if you use like gates or yeah, gate logic for the digital part. Or just transistors. You can still use transistors, I believe. But you could still use a logarithmic. Let me check that. Log function. Okay. So basically, this would be the voltage. This is the exponent. So we can convert the exponent in like with log to the voltage that's stored. So we can have quite high exponent. The precision basically drops the higher the exponent is, but that does it matter? Yeah, it always matters. Damn it. Do we have even like an analog exponent? Yeah, but this is okay. We won't be able to find it. Also, you need to somehow. I mean, if you don't have a clock, you just wait long enough for every voltage to settle, and that's the color value. So the precision will increase with the time that you let pass until you lock the color in, or it will just like if you have 60 FPS, on average, the precision might be alright for each pixel, or I don't know. I mean, it needs to be really fast. If we have like a clock of 25 megahertz, fades in or something. Yeah. It will probably warp or some even. If you have like, let's say, the precision of each like vector multiplication would like bend the vector in some direction. It might like oscillate and then, so it probably if you're rendering a sphere, it will like wobble or something with time. No, it would wobble per pixel. If you have like per pixel an individual implementation of the whole circuit, which would be amazing, but this is never achievable. Only if we do a small resolution, like the next analog supercluster. We use one of the square displays here, this one, and make a ray tracing analog circuit for each of the pixels. Then we will see the wobble. Wobble. Ball PC. Exponential amplifier. Oh wow. Okay, there's a lot of interesting stuff. But imagine if you have like all the blocks figured out, and you can even run a simulation with Spice or whatever. I don't know how you simulate stuff, or with what was this browser thingy for analog circuits. So we can test that and just order an assembly from JLC with really small components, and then you have a rendering pipeline for an individual pixel, and you set the vector with knobs, or I don't know how. You can set them with a DAC if you want to. And the output will be basically an RGB value. You need to dial in the coordinates of a sphere that you are rendering. That would be funny. Okay, let me paint that. Okay, so imagine what do we need? We need we have like a vector for the position. Yeah, that's what I'm also using for the last array that cluster that I made. But I still had like to convert to float before I did the fast square root to use the magic number and the exponent. That's why I'm like refreshed on floating point conversion and stuff. Hey Chris. So we have this is like 0 here, so this is 0. So we have the position of the viewer, we have the view vector, then we have the sphere position, which is also like from this. So we have 3 vectors. Oh yeah, we have one vector, this is like it's not a stick figure, it's a ray tracing thing. Okay, and then we have also radius. Okay, so radius, and then we have RGB. So the color of the sphere. Okay, so this is the view vector. So we need this as input, this as input, this as input, this as input, this is only a single value, and this is input. This is also a vector. So we have 12, 14 knobs. 13 knobs that we will have. Did I miss anything? 13 knobs per pixel. If we have like really fast darks that we can use for setting the view position. Oh yeah, we need light. Oh no, you're right. Okay. We can do either hard coded or we do actually a light a vector like that, like for the light, which is also like this would be the light vector. We need to draw it from the origin, but it's only a directional. This is hard. Like the shading takes the most. Ray tracing the sphere one by one screen. No, if we continuous. Elaborate, Sonic. I don't know what you mean. I mean, if you let's say we are racing the beam, we have like an analog CRT or VGA output. So we have for each. Okay, the position is changing, but this would be an orthogonal. Like for each line, we are changing the position here, so this changes for a frame, so this is changing, and also the view vector is changing. This needs to be normalized, but I think normalizing is easy if we are using the exponents. We just drop the exponent and we are done. No, we don't drop the exponent. We have like the sorry. From left to right sphere, it's lighter continuously, then darker again, no pixel on. Oh, you're right, yeah. If we're like interpolating the view vectors, if they can change per line, like let's say we have this view vector for our viewport. It will just change, let's say, the one of the values, which will slowly move over like that. You can do it. You can, but timing that correctly. I'm not sure if this is what you mean, but and the SDF, we have always like the distance function. I'm wondering if it's possible. How many gates would we need to, or op amps to calculate that? That would be ray SD. Ray tracing might be easier than ray marching here, not sure. Andy, you're hooked. You're hooked on this one. This is your next mixed signal tiny tape out thing. Yeah, maybe so. I guess rendering the doing the inverse square root, or like the square root. We if we calculate the distance, then it's just a comparator which decides if we have a hit or miss. I bet it's quite easy to set this up. By the way, your explanation for like you mentioned in your write-up that torus rendering a torus in the way you did it is easier than a sphere. Is that right? Did I understand that right, or did I get it wrong? Because that immediately triggered me. Yeah, that triggered me. Yeah, so that basically that triggered me. That can't be true. It's easier than that. You. Yeah. I almost wanted to take upon the challenge to do that, but I didn't spend too many thoughts. Okay, cool. Yeah, can we do ray tracing like at least one pixel and then edit in some way an input? Vintage Computer Fest. Oh, wasn't like the 8-bit guy there. I think he didn't he make like a video on that? Did you make wait. Retro Computer Festival. Oh. Vintage. Is this the homepage? Am I right here? Oh no, that was last. That was the last one. Oh. Oh. All right. Yeah, we have to think about the analog stuff solution. It shouldn't be like very complicated. The only thing that we need to figure out how to represent like high values if we do an exponent or whatever, or if we can work around that in some way or form. I mean, if we store the values as logarithmic values, not as like we don't need the exponent if we use logarithmic values. They are more precise in the lower values and then less precise in the higher values. So yeah, why did I think we need like exponents to be? That might work, but logarithmic values don't work with negative? Hard in log space. Yeah. If we have Oh no, if we calculate the length, then like under yours, yeah, where was the square one? Okay. Hey, Flyken or Flicken. Oh wow, Wemos, that's a long time ago. Nice. Flyken, okay. It sounds like you're building drones. Array, sphere intersection. Here we go. That's only like, wait. That will be the issue, like the subtraction underneath the, because yeah. Okay. So much text. It's like your automatic voice selection on Twitch for TTS is really slow. Oh, now it's fixed. Radius, yeah. Squared. So it's not much that we have to do here. Yeah, I think no worries. Welcome to the stream. Yeah, that's something that I have to think about of thing. Another computing for Raytra is on a microcontroller. This is hardcore. Yeah, foo. Not microcontroller. If we can, I don't want to use a microcontroller. If you can imagine that we, like, if we can use a simple thing just to find the sphere ray intersection by having like, what is it, 30 knobs, and then just seeing the output signal without shading even. That would be already amazing. Vectors end loop. Oh, tape loop, yeah! Analog tape. Video. VHS. We take VHS and we take the RGB colors as the input vector for the. We can use. We don't even need to change position. Position can be dialed in, and we ignore the screen. We have like, if we can always start from one point. So this doesn't need to be changed here. The position. I'm wrong about that. So this can be dialed in like a constant. This is a constant. This is a constant. This is the only thing that's a variable. Then we have this is constant. This is constant. color is maybe constant. So if we use, imagine we can just use basically a VGA output. Okay, this is getting cooler and cooler by the second, by the minute. So we have VGA and we have R, G, and B, which are not the color. It's just representing, it's just representing this vector. The sync signals don't matter at all. So we just need, like, I don't know which pins these are, and ground. We can just use, like you would do a ray tracer on the graphics card, where you just draw a rectangle with the vector, which just interpolates the view vector, and then do everything in the pixel shaders, basically like that. We have this is cool. We just draw a gradient to VGA. We get clean 1 volt signals here. This is 1 volt, 0 to 1 volt. Toot, toot, toot. So we need, like, bias it by 0.5 and multiply or whatever. So we would be able only to do positive view here, or we divide it and everything is just biased by 0.5. No, we can't do that. Yeah, only the input. We need to work with negative voltage, or we need to, like, have the bias somewhere higher. I don't know, not sure yet. But imagine that this is VGA is the input for the view vector, and we have just some dials for the position. We have knobs or trim pots or whatever. Here, this vector. Then we have this vector here. More trim pots. It's, I don't know how we will represent them. If we do, like, in log space or whatever, this will be tough to place it anywhere far away. RAM traces. Yeah, we do everything on the fly. We don't need any RAM. We only need, like, some trim pots. RGB, we can do more, like change the base color, but there won't be any reflections yet. No reflection pass, since we have only one sphere so far. Yeah, it will be hard to. Yeah, we can do with some comparators to see which intersection is closer to, if there is an intersection, and which intersection is closer to our origin. Wait a second. Since we are rendering only one sphere, we don't need the position. The position is always origin, and we just shift everything around. Like, the sphere is shifted, so we don't need this vector. Wrong. We only need this one. We start always the viewer is always in the origin. Displayed on the scope. Yes, I'm with you, Toshipu. I'm totally with you. We can do even, like, the scope XY mode and RGB since I think like one of the vectors is always it can be ignored. It depends which direction matters for the gradient, like which color matters. We use x and y as the position, and the output will be basically, the scope has like this additional channel. What is that? I think, how is it called? Is it here? External trigger. No. Is it that? Z. Yeah, there it is. Z for intensity. Here. So, are we hooked? Are we hooked yet? I just talk and inspire, and I hope Andy will just resolve everything and make a draft for the analog circuit, and we can discover that. We do a ray tracer, analog ray tracer. This is the next one to do. I will put it. I need to, otherwise I will forget that I ever mentioned it. I always forget everything that I do on streams. So I will put a note here. There's a note block. I will write analog ray tracer with VGA as input vector. Do I have a pen? Does this household have a pen? Here, there is a pen. I have a pen. It doesn't write. It doesn't write. Oh, it writes. Okay. Okay, here it is, the note. Let's put it here. Enough of the distraction. We only need the position of the sphere, the size, the radius, and maybe the color. We don't need the color even. If we just start with the 4 input values here, we're good. It shouldn't be that hard. Peeps. How hard can it be? Birthday. Oh, bye bye, Jody. Let's reduce it to the minimal thing. Demo scene from last time would be nice. Let the AI bubble burst. I'm such an ADHD kid. We need to find the length. Okay, let's see. Let's refresh what we can remove. center ray origin. We don't need, origin is 0. So L is equals C. L is dot product race direction. L is the center. Yeah, that's what we get for the sphere center. So we have, this is L, this vector, since we start at 0. Then we do the dot product with the direction. Unfortunately, we need to normalize the z component for that. So we can't like spare one of the multiplications like that is going in z direction. Okay, what do we have? That's the distance squared. Okay, ray sphere L dot direction, so we need that. Then if it's negative, we quit. It's looking the wrong direction, like it's behind us. Then we can ignore this case if we are always looking in the direction of the sphere. And so we would need only this part. Let me write some notes. Visual Studio Code. Cluster, maybe we put it here. No, we should do a new one. New window. Yeah, let's open a folder. I'm now intrigued. We will do it this year. We will build it. If it works, it works. If it doesn't, it doesn't. Okay. Let's just elaborate a little bit. Oh, maybe I need a folder for code. Okay. Let's do new file. No. Maybe we should do the README in the top level here. Okay, so let's take this piece of code. Code block. What? All capital? No. Never. Okay. So, it's a convention. Okay. Yeah, I can't Okay, we are on Windows, so the issue is now I can change the name, but I need to change it in a different name first, otherwise it wouldn't be changed. Weird, but it is like that. Okay, Fu, I will respect you. You're funding this channel, or at least the excavator for this channel. Okay, let's change it. This is let's take it from here. Do you enjoy it so far? Which episodes are you right now? Maybe I should. Oh, yeah. Okay. You will notice she's a Karen. Ah! No! What? Okay, here we go. Source. There is an extra space. Ah! Here. Can't click it. Okay. So let's reduce it to here. Okay, code block. We don't need that. So let's do L. Origin, okay. Then we have direction. Okay, yeah. We need this direction here. Hoppala. Code, yeah, TC. Return false. Then we need the square root, which is TC minus yeah, that's L. Okay, we need that. Return false. Square root. So basically, okay, this is where we can optimize. Basically, instead of doing the square root, we can compare with the square. So basically we could do, but do we need the square root? The distance is times 2. We use the square here, So we don't even use the square root. So basically what we do is this. So let's optimize. If d2 let's do load and then yeah, in this point we basically changed all the code so we can drop our example here. Um, am I not missing something? This is basically what we calculate here already. So if we do that, this is so I can't okay. How do we call it? Let's call it C. It's basically that here. Minus d times d. And then it's basically if d is bigger, so if c is then 0, return false, tc1, t1c, okay, let's call it t1c then. No, t1c is with, so t1c squared, and t1c is basically square root of t1c. That's why we can't, like, if there's a hit, we can't do the square root of negative value solve intersection points. So that's basically the negative. We only are interested in the first one because this is already the distance, so we don't care about that one. First hit is good enough. That's basically it. Let's the comments are not necessary. The solve comments, square root, solve intersection points. Yeah, no, we can do that. Oh, damn it. Intersection points. Return true, return false. That's basically what we get. We can also wait a second, something's wrong here. Yeah, we don't use it, but this is basically the distance. We're not using it right now. We know true and false is basically, if we do some shading, that might be interesting, but there is like more and more going on. So good enough. So if we are calculating, we would need like to calculate the normal, which would be in that case L T1 times dir minus L or plus L. That would be basically divided by R is the normal vector. So that would be the normal if we do more stuff. Let me check that. Yeah, I think this is the normal. So that would be the normal if we want to do, but we don't do anything. So actually we only need, we don't even need this here. This part is also optional. So to calculate if we see like this sphere or not, we only need to only a few things. The dot product here, let's copy that. So this will be a comparator here. If we don't even need to do the calculation, we need only the multiplication, and the negative is just a comparator which will decide if it's bigger or smaller. Easy peasy, huh? Okay, so let's copy that. Ah. Wait. Come on. Close it. No. I can't. Ah. Shit. Destroyed it. Damn it. I need to add something at the end. Otherwise, oh, weird. Ah! Where's this coming from? What happened? This editor thing is really... Okay, let me change to... Can I use not... I switch off the markup here. Damn it. It's destroyed. It's destroyed. When I do tab, it only... Blah. Okay, we are back. Okay, now let's do... we need that. We need that. I was calculating. Oh. No. Here we go. Huh? What? The markup parser is... We only need these things. Hey, come on. Why is it doing... Why are you doing this to me? I know you have like... Nope. This is painful to watch, isn't it? Can I turn it off? Toggle edit mode. Split view. Okay, let's do split view. Oh yes, please. How do I do it? To not get negative values. Yeah, but I will have negative values anyways. I will just use a comparator here. So how do I write in this markup? How can I write a multiplication without... Where is the dot? Give me the dot character for dot product here. Here, UTC for you. And we remove that. Compare. If we can even spare the multiplication here. Wait, can we simplify that? Wait, why did I do D2? Where did I miss D2? Wait, what? No, yeah, that's D2. We have D2 already. Sorry. So we don't need a square root here. Easy. It's reduced to only these things here. Okay, we need multiplication, addition, subtraction. If we look close enough, okay. Can be big. Let's do that. Then we have here normalized. That's basically between -1 to 1. Then we have R. Can can be big. Use. Since R2 is like fixed, we can pre-compute that. So the input would be a square radius, but later if we do light calculations, wait, that's wrong. That should be divided by R. But we don't need to divide it if we normalize it. Okay. So it can be normalized instead of dividing by radius because the normal. So actually we can use as input R squared let's do R2. We can save some of the circuits here. This is just a comparison. We have multiplication, subtraction, and addition. The issue is this can be large. This can be large unless we specify it to be like really, like the radius, either the radius really small, but then we lose precision. If we have like our space, if we define it like that, okay, so this is our space. If this is our space, let's say, Christian, we are developing the minimal analog circuit to render a sphere. We have like this sphere, which is basically, this is our origin. So this is our 0 here. And we have viewport. This is our view vector. So let's rename it. That's deer. We can call it just D. Yes, it is. That's a ray tracer, and we will. That's a view of the space from top view. Top. And this is basically the screen will be like that. So. More or less. We don't have a clipping plane or anything. If we keep everything within, let's say, here, this is the coordinate system. This is minus voltage VCC. No, we can do VCC half. Or we can do, yeah, VCC divided by 2, and this will be basically also VCC divided by 2. The bias needs to be done at some point, or we have negative voltages. If we operate on negative voltage, it will be easier, most probably. Reuse the laser PSU. Yeah, we can just define. No, can we define the new ground? Yeah, we can do whatever we like. Can just work with negative. Okay. This is V and this is V. And this will be V. So if we operate within that range, let's say that will be, we have some clipping because of the op amps, they can operate really high, but let's say this is 12 volts. I really don't want to work on such high voltages, because that might fry if I set up something wrong. There can be any voltage. That's oh, we need to square stuff here. Radius can be, gives meaning to breakpoint. Yeah. So the radius square needs to be everything. If we use like anything above like, let's assume we use TPU for fluid sim cards. Tensor processing, yeah, sure. It's just multiplying matrices. The Navier-Stokes, you just iterate, it's a differential solution, you just iterate through, it's like plenty of matrix multiplications. Probably perfect for that. Or am I wrong? I might just talk bullshit here. Okay, so it's basically square of 12 volts. That's the radius. Oh, you can see. That's the radius, maximum radius can be that. And what else do we have? What else do we have to consider? That's TC. Okay, so there is even more. The problem, YouTube says it was streamed 9 hours. What? Wagon, did I set up the wrong time for the stream? No. I might have, I'm not sure. Weird. Okay, sphere position. So we have a lot of squares here. Weird. Yeah, okay. Christian, that's on Twitch, but YouTube is something different, maybe. We have some squares here. So we should always stay below like 1. In that case, the values only get smaller, not bigger. They might get above 1 here. Oh, weird. Sorry. So since this is a dot product, we get basically voltage that can be 3 times 1. So like if we would say we normalize everything to plus minus 1 volt, the dot product can output something that will be 3 volts, or yeah, from 0 to 3, because it adds 3 values here. Then we subtract something, this is square, so it gets smaller than 3 again. So 1/3 direction is normalized. Bye, Fu. Thank you for the donations. I will take a bathroom break, and I think we will switch to bodging the PCB here, because we can solve everything, but I can take notes so we don't lose everything, all the thoughts. So more use. Yeah, the board, it works already like with one MCU, but I want to see like 2 MCUs appear, and that's what my goal for today is. And I want to maybe stop in hey Kasper. Kaspar, did you get your tea already? Yeah, we had like a few thoughts on doing an analog ray tracer, and as input we take VGA for the direction vector, and the only thing that we need to do is multiply, add, and subtract. Or it's not, yeah, this is multiply, but we have also like this is a square. Can we square it there? A square here, and wait a second, something's wrong here. What did I mess up here? $600X? What? How did you do that, Yombo? Show on the web, or never happened. Do you have a web version? Okay, I will take a bathroom break and be back in a second. All right, I found Madeleine's. Tony, I almost ate my headphone. Ah. I'm missing something. Is this a dot product as well? Most probably. Alright, peeps. Let's move on. Ah, the Midlands. Tony made them. Amazing. Ah, they're excellent. No, they are not shorted. They only look like that. We need to ground those here and these here. Wait. Okay. But where's the other one? I did this here. So ground, 3, 3. And here also ground, and here ground, VCC, and ground, VCC. This cap is added in the newer revision. So it's just always rotated by 90 degrees. All right. So let's do that. That's easy. Maybe I will add a small view here so you will be able to see what's happening on the table. Let's stream really fancy. Boop. Here. Hey! Thank you for the bits. Yeah, we are fixing the RP2350. Bodging that. Easy peasy. Still very tiny wires though. Even if it doesn't look like, here is a hair for comparison, size comparison, quite small wires. I'm just using I will just use multi-strand wire and or should I use the copper from it now? Let's just use the multi-strand wire for that. Oh, I still have one here. Let's start with that one. I need to here, right next to the USB. This pin and this pin need to go to ground. I can just short it by exposing the copper there. Oh no, where is the... grind it off, but I need to... I will use a tool to do that. I hope it's still charged. Otherwise, nah, it's not charged. Ooh. Ah, yes it is. Get the light closer. I have no clue if there is Wi-Fi, sorry. This is my first board that works. That I might be, I'm not sure. I don't have a working prototype board of that, or a dev board, standard ones. I just started with designing my own ones. Okay, I think this is good enough. Yeah, I don't have Q-tips. Ah, damn it. Okay, let me get some Q-tips or swabs quickly. Okay, just need a container with some IPA. My ultrasonic cleaner still has some IPA, so I will take that. Let's meet that just a bit there. Here we go. It's quite big, huh? Maybe I should record as well. Oh, that's not as much, but the copper. This is the RP23 54 board with 4 MCUs and I need to bodge it because messed up the circuit a little bit. And turn on. Light is in my way. Okay. The board is just a curiosity project. Fuck. Can't do it like that. I would need a chisel. Now we got some. Okay. Good enough. My tools are not sufficient. Too big. Okay. Flux! Flux time! Oh yeah, way better. Here we go. This one was fixed. Okay, contact should be alright. Tough call here. Oh, this one is even already contacting. Maybe we can, yeah, I will use the wire. Damn it. Why is it so finicky? It's a botch. There is an error in the PCB. Need to ground. Damn it. so close to this resistor. Okay, I think I got this. I will do it like Louis Rossmann. Okay, next one. That's like a little strand from a multi-strand wire that we can use. Like one strand is enough to watch all the lines here. Oh, dusty already. I feel like my positioning is suboptimal. This is gross. You know how small this is? It will take me just as long to put the Kapton tape there. I'm bodging my messed up. I think we are good with this one. Okay, these should be the two grounds. No, this isn't. Ah, fuck! Oh yeah, I forgot that the PCB is... Alright. I don't mind dirty jokes. Or dad jokes or whatever. I don't mind any jokes. Yeah, maybe some jokes. I have a reputation to lose. All right. Especially self-deprecation is welcome. But let's not overthink here. Fucking light is in my way. Can move the soldering iron. Yeah. Unless you have a twin. gunk here. No, I can't do it. Need to use a different orientation. My soldering iron is constantly hitting the light, but I need the light quite close, otherwise I won't see anything. Can't see shit. But I think it should be. That's alright. Demonetized. Okay. How do I get it over here? Let me remove some of the gunk. Go. 3.3 volts. Ah, damn it. Again, cursing all the time. Yeah, I need to put some first solder on here. That will hold. That's 04 or 2 components. Don't be mistaken, thinking it's. Oh, maybe we can increase the sharpness slightly. That's also you see, like, there is no. Yeah, it's quite tiny. STM. I really wanted to, and I have some STM MCUs here, but it never, like, I never had the opportunity because I don't know, too many other projects. About what? What did I heard about? Fly pen. Is this like a soldering iron? Oh. Okay. I think I will just bend it over. The interesting thing is we can immediately test how that will work by plugging it in, and we should have 2 devices that show up. Here we go. Uh-oh. Please don't break. No, it breaks. actually right. I think there is plenty. I just need a sharp, yeah, detached. Painful to see that botch. Oh, you're right. I should change that. And here we go. Seems it was a cold solder joint anyways. Here we go. Alright. Let's check it again. It looks gross and should work. Alright, let's plug it in and see what happens. I will switch to the desktop. USB cable. Boot. Button. E and H. 2 drives. With 1 button. Okay, 2 more to go. We exposed the pads. This is cool. Look at that. I'm so cheap. I used 1 button. 1 boot button. Here. USB boot. That's just connecting to all of the MCUs. Okay, we have like 1K resistor, but 1 USB, 1 boot button is putting all the MCUs into boot mode. Oh wow. Okay, more bodging. You know, the initial intent was to use 16 MCUs in parallel. Imagine 16 drives appearing. What will happen if you run out of drive letters? How many drive letters am I using right now? Let me check. Oh yeah, I will definitely. No, if I have 16, I might be good. I'm using C, D, F, G, K, M, P, V, W, and Y. So we have 6, 7, 8, 9. Oh no. I might need to. Yeah, but will it do automatically? I mean, it picks any drive. Other alphabets? No, Polish alphabet. W. Ch, L, O, Ż, Z. That will be cool. Polish. Can we no, we can't force it from the MCU. Polish alphabet. That would be amazing. I would call it Pierogi MCU. A bowl of pierogi. Okay, let's continue. Let's continue our... Oh no, did I lose my strength? Yeah. Yeah, no. I have more. There is more. Here. Multi-strand wire. We have more strands to work with. Whoop. Futurama alphabet? What is that? O N Q N U J J. I can see it from this distance. W. You missed the W letter. What is the W? Where is the actual one without? It doesn't have like. It isn't an actual accent, is it? No. Text to speech said L, not W. Strange. The only weird thing about Polish letters is like Y. Y is called Y. It's a little bit weird. But we have similar weird stuff in other languages, like in English it's W. Okay, that one worked well. Maybe because of the fresh wire. Oop. Oh, that is already bridged, but it will probably break. I hope not. Greek? Klingon alphabet. Kapla! Dothraki. But they don't have written language, do they? The Dothraki. Valyric. I need more flux, I believe. I'm done with season 6 of Game of Thrones. What a coincidence! Right after we started watching it, the new show was announced. I hoped they would continue with the, what was it, the Dragons show? What happened to that? Oh, I can't see. I think it's connected. House of Dragons, yes. Is that coming soon, like a new season, or are they basically done? George R. R. Martin is just as bad as with finishing things like I am. Did he write the last book or the last books of Game of Thrones, of Ice and Fire even? Not sure. Yoo-hoo! Oh, that works way smoother than the other. Yeah. How do I even approach this here? Wait, I think I need to I can't see if this is bridging or not. This ground. I will That's most probably. I need money. Why shouldn't I? But I have like was the there have been projects where I never made a video about. Oh, what is special about the Futurama alphabet? I never knew there is like even a special alphabet. I can't see here. Come on, do it. Oh, damn it. It broke in another place. Here. Bender. Oh, what's going on there? Oh, now I can see. Different computer. Okay. Maybe pretending is the thing. Oh, that's cool. Okay. At least working with these tiny pins, it's easier to get them heated up. The only thing that's harder is to okay. That looks even better than the one before. Let's test it. Okay. Here we go. Uh-oh. Here we go. Uh-oh. Can't see booting up anything. No drives. Did I short something? Let me check for shorts. Or is boot now not working anymore because we have more than two? Uh-oh. They're there? No. Not showing up. Let me check again. I'm wondering if there is like a threshold of how many you can hook up to the boot pin. Oh, I guess I guess this one here didn't make contact correctly. Okay. And it looks alright. No short there. Let's make sure there is no wondering if this is good enough. Oh shoot. Okay, now it's certainly solder bridges, magic smoke. Yeah. Something like that. Let's do a swap for comparison. Okay, the swap loses some hair. Okay, let's try again. If it breaks, it breaks. Doesn't work. No, it doesn't break out any GPIOs. Something's getting warm here. Okay. What is the thing again? USB view. Nah, I don't think it's that. They're looking all right. Oh yeah, I can test that. No, none of them is booting up. I hope I didn't break it by shorting the USB with ground. Could be here. something really pointy. And the tweezers are not pointy enough. That's almost like the most pointy things. So we have nothing here. What is this crap? Really crappy connection. Yeah, this is grounds. Need war. Where is it? Oh yeah, maybe this wire is touching. But in that case, we have just probably a shutdown of the 3.3 volt line here. Okay, let me check if that is the issue. Not sure if this is even connecting here. Can't really. Oh. Yeah. No, it's certainly not. Damn it. I need to fix that. Yeah, more flux. I jinxed it by saying it's working, it's going more smoothly than before. Hello, who's there? Can't see the name here when I'm at the microscope. Ah! Oh, is the wire now connected to this? Damn it! I'm doing fine, or who is asking? Who is asking who? Can't tell. Ah. Now these two pins are okay. We separate everything. There is like still this wire. Okay. I'm doing fine then. Oh no, I never should have used this single wire, like this short piece. Oh, I have it removed, but now it's touching the USB. Okay. I think this is good now. I just need to attach the other one again. Which is hard on its own. These are my finest tweezers I own. Can't tell if it's contacting. Might be not. Yeah, I have text to speech, but doesn't reveal everything. Okay, I think this is good. Now, this one is probably touching the ground. Okay. Once again, either it's fried already, or we see now 3 drives appearing. This is my... Yes! 1, 2, 3. Yoo-hoo! Look at that! Look at that! Mass storage! Mass storage! Okay, RAID. Yeah, it's a RAID 4. No, RAID with 4 drives. Let's fix the last one and then we are done. And I show you what it does. It has a 10 line connection from each MCU to each other MCU, so it should be able for whatever reason to do matrix multiplications or whatever. So look at that. That one is connected to there's a connection between A and D. This is A and C. This is A and B, and this is A and B, B and D, B and C, B and C, A and C, C and D, and this is C and D, B, D, and it's always, since it can run always like the same firmware on all of them, it's always connected in this direction, like I don't know, like just shifting by No. Yeah, something like that. LED matrix. Oh, wow. That's which one? So now let's. Okay, last one. But it seems to be resilient. At least something on my circuit is resilient. Whenever there is a problem, it just doesn't boot up. We didn't fry anything so far. Hey, Quindor. If you're wondering if the 6-layer board arrived, unfortunately not. It will arrive in the next 2 days. So next week will be either already assembled or assembly time on stream. We'll be testing the array, but now we are testing the RP2350 array, which Thomas, who isn't there today, was able to figuring out what the issue was. It was quite simple. Quindo, by the way, since you have been there when we tried to figure it out, as far as I remember correctly, it never was the crystal. Shoot, that's too much. No. No, what did I do? Too much soda. Just need to heat it up. No. I think I need to. Yeah, no worries. I had to rage quit on this project. What is going on there? Yikes! What did I do? No good. Let's clean it up. Here we are. We had a connection to the board. Oh, there is even a bridge. Funny. So it knows where to go. Let's add some solder to the end of this wire. And now convince it. Oops. Yeah, it needs to be. Look at that. This is what happens if we don't have enough flux here. We're trying to solder to the ground. Damn it. I don't want to touch. I have enameled wire, but I don't want to use enameled wire here because I don't want to. Why is it? It is leaded. Yeah, I don't know if it's long term a good choice for me. my health. I have a fan here, but who knows. Okay, I think I finally got it. Yeah, that it might be a game changer for fixing stuff, not like base work. I mean like prototypes maybe. Yeah. Apparently, seems to be connected to the ground bed of the chip, because that's not heating up at all here. Okay. Human hair for comparison? Here. This is the human hair for comparison. So the scale we are working on, this is here for 4 or 2 components. And I need to, I don't know, what is it, 0.6 millimeter pin pitch. I need to attach to the one directly next to them. Nah, not really today. Looks really shaky though. Should grab it closer to the... Oh fuck! We have 3 working right now. Oh! This is the last one. This is one strand of a multi-stranded wire. So, I guess it's 50 microns. No, or 100 microns. Let me check. I have 100 micron enameled wire here, so we can check that. I believe I'm connected now. That's shit. Yeah, let me get some flux here. Here, this is the flux syringe. And this is not a big syringe. Oh shit, I lost my ground here. Okay, let me do this first and we fix the ground later. Okay. Let's get that ground fixed again. No! Ah! Oh, it's a gamble. Wrong. Wrong. Fuck. Where is it? It's on the tip of the soldering iron. think we're there. That's alright. If it's still sawdust, it's alright. Alright. Now we need to put the VCC in the third dimension. I mean, we can bend it up. Yeah, what is the Da Vinci? Da Vinci is the surgical robot. No, it's Leonardo, not Da Vinci. Or is it? Yeah, I think it's Leonardo. No, it's Da Vinci. The surgical robot which can be used remote or brain surgery or what? Oh, scheiße. Yeah, I mean, it's always used for some coils. You can just take any coil apart. What? Is there an earthquake? It's the issue here with the lead-free solder on the pad. I didn't assemble this one, so I mean, I'm using bismuth, so bismuth solder, so it's even worse than this lead-free one. Okay, now finger clippers, you know. Like I have like regular clippers, which are really fine. Look at that. These are the clippers. They're not big or anything. So good luck with that side. We are connecting random pads to random wires. One VCC is left. I'm fixing my my mistakes here. I'm wondering how I will solder underneath that. Yeah, there is no way. Move it back a little. And then I hope this is pre-tint. No, it will make them work at all. They were not booting at all. I'm just when I'm pressing the boot, they either appear or not, and currently they're not booting, so they're not working. They're not starting because what I missed while I was designing this one, is this still my hair on there? Yeah, that's my hair. So you can see the hair is around about 50 microns, so this is probably something like 100 microns, 150. The wire that I'm using. Very small. What I missed is that the internal voltage regulator of the RP2350 needs to be connected to VCC and ground, even though if you're not using it. The thing will not boot up. No matter if you supply a different, like, a hoverboard. This stupid, it's bending away. I am trying to hold it there. The tweezers. Fuck. Sorry. My patience and my steady hand isn't steady anymore. My patience isn't. Thank you. DDR5 RAM. No. That's not my scale. This black DDR5 is black magic. I'm working in megahertz ranges. Sorry. Sorry, mate. That needs to be done by the professionals. I'm only a hobbyist here. What's this? Shoot. It looked like it's attached, but it was cold. You know, if you hold back your emotions too much, you will not live a healthy life. Yeah, DDR5 needs to be really, really close to the CPU or GPU, whatever. What's the maximum distance of DDR5? Come on. Isn't there any solder? You need an interactive beep sound. I can't really see if it's connected or not. Wait, the gong is in my way. Yeah, right. Let's move away the gong. I need a lot of light, but the light is in my way. And I move it closer at this scale. I need more fresh soda. Clean tip. This is the worst so far. This pin doesn't want to connect. It probably is already, but it doesn't look good. What the fuck? Now I destroyed everything. Oh no. My ground is connecting to VCC. No, we have to start over again. Oh shoot. Yes. Yeah, I need to remove that one. Let's bend it away. Damn it. Brussels sprouts. I clean the tip with Brussels sprouts. Okay, let's start over. I have no clue if there is like... Yeah. Can't tell where... Yeah, I don't use any special treatment on the tip or whatever. Only the brass thingy. The brass sponge. Whenever you hear like the bell sound, that's this is my sponge dipping. Doesn't attach. What the... I think the issue is the solder on the... Yeah, now we refresh the solder there. Let's attach it. Ah, that's much better. Betterer. And now, since this is VCC, just move over here. Fixing my board mess up. That's alright. There's probably some warning symbols on. Because you can select the voiceover, language that your voice is based off. You have a database that's stored, so there is some distinction between the individual people that are talking. All right. Oh no. What should I use? Fool. Yeah, enameled wire still needs solder to attach, doesn't it? And you need to like get off the insulation of the tip. So I actually don't see the difference. I mean, no, this is not solder. This is just a strand of a wire, of a multi-strand wire. It's not melting. Not sure. I don't think this. I need higher. No. It is. Yeah. That's the issue. Use exclamation mark help for the. Okay. That's attached. Ah. There are not all languages implemented in Google Chrome. So which language did you pick? Oh, dude. How often will I be asked that? Because I don't want to care about the insulation. Okay. This looks messy. This looks messy, but this is the last. Still the same, huh? Okay, that's attached. I'm sure it's attached. Okay. We need to take care that. No, I detached it again. Come on. You can do Indian. Here we go. I think this isn't touching any other pad. That looks alright. Did I bend any of those? Nope. Nope. This one looks really sketchy. But it's not touching, it's only messed up. Okay, peeps, let's try it. Let's try it. You need to do Indian. You need to do en dash and then I think Hindu. No, I don't know. Okay, here we go. Boot button and let's plug it in. Oh no! Did we get 4? Yes, we have 4 RP2350s. Yoo! It works! La 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 la. Nice. Here we go. Now firmware. What do we put on it? MicroPython? No. It's so weird. We have a hub with four USBs on there. Ship it, yes. I mean, it's on GitHub, so it doesn't need to. But what do we do with that? I have no clue. There is like a dev. Oh, it's 2350s, not 2040s. You're still here, Andy. Do you have any recommendations for 2350s? No worries. You're probably still designing an analog ray tracer, are you? I'm back for a few moments. You need to leave to get some analog components. Ray tracer with tubes. Let it sink. One sleep, and tomorrow you will wake up with the solution. But I will certainly build one this year. Je suis française. All right. Yeah, Usagi Electric, yeah. He certainly is a madman to do something like that. The silence. The extractor fan is so loud. I need to build a new one. Alright, what do we put on that? Je parle en français. Français. Oh. USB hub. Yes, that's a super cheap few cent USB thingy here. Just a hub which doesn't even require the crystal that's on there. Hey, let me show it. Wait, I can. Here we go. Whoop whoop. Focus, focus, focus. Okay, this is the hub for USB hub, and these are the 4 MCUs that can talk. We could even debug them. Jag pratar svenska. Yeah. Now you see the scale of the bodges. And this is clipping. Boop, boop. And this is the wire that we were soldering. You see that? This is the wire that we were soldering there. Oh, memory card full. Real slushy. Hello. So this funny thing. What do we put on it? We can't do anything because there is not even a single LED on that board. It can play ping pong. Color me impressed. Well, what? Jeff? What? Yeah, I'm worried if I put it in an ultrasonic box, it will fall apart. It's held up by the flux right now. That was what you're thinking? Yeah, they playing ping pong. No LEDs. Yeah, it's not a real Looney board, huh? This is the board. It doesn't have anything. Yeah, and it's badly laid out. Look at the crosstalk going on here. But on four layers, there was not much possible. Six cores. I mean, aren't they dual cores? So we have 8 cores, and each of those can communicate individually with each other of those. So, but only simplex if we have like 8-bit at a time. No, half duplex. Yeah. Basic VRAM. And map a GPU. I have no clue. I mean, it's USB 2, so we can't do actual GPU, but we can ray trace something and let it run from over serial. But I would need like, I think it's too late for that for today. We can run. How do you? Do we have like a IDE for that? Oh, we can. Yes, I have Discord. Discord is, here's the link. Oh, Dutch, you were faster. All right. Okay. Raspberry Pi Pico IDE. Oh, what? Getting started. Okay, here we go. Getting started with. MicroPython. No. Raspberry Pi. Let's start. What do we use for that? How do you develop with that? Honoka. Yeah, you can just join. VS Code. Yeah, probably. I did it before. What did I do? PCB code. Wait, what? No, this is. Wait, Blink. What is? Oh, this is not. This is 2040. Pi Pico extension. We have probably Pi Pico extension. Raspberry Pi Pico project. Oh, Rust. Nice. No. Here we go. And what now? Okay. Here we go. Yeah. Risk V. You see, I'm really terrible at this. Project name. Ini de Beninging. Ini de Beninging. Okay, this is our. Oh wait, there are examples. Select an example. Okay, but we Ini de Beninging. Okay, which one is it? Pico 2, Risk V. It's interesting. What should I blink? Blink any simple SPI. multi CDC. I want just a single CDC. Yeah, I never watch my streams. PWM RTC serial. Or do we do like MIDI? Serial. Hello serial. Change. No LEDs. Oh. Select. This should be, I paid 150 bucks for this assembly. How much did I pay for this assembly? It was gross. I don't know why. Debug probe. Debugger. No. Show advanced. We can put LEDs on the debug pins on the back, like we have on the back we have the SWD and clock pins. We can just solder on an LED there. Do we create? Do we just create? Oh. Here we go. Heatsink. Okay. Compile. Okay, I will open them. Okay, they are here. Can I just run and it will pick? Targeted? What is the... Hello serial UF2. Okay. Let's reveal in File Explorer. Uh-oh. One is missing. No, it's here. Okay, I can just drop where is it? Huh? Reveal it already. Here we go. Okay, what does it even show? Hello serial. Hello serial, my old friend. Hello world. Okay. MCU 0, okay. Oh, the switching regulator. Python, no. That's C++. Okay. RP20. Okay. We can just move this one. Okay, this one is programmed. Now we will use MCU1, build it. Yeah, it uses spaces as steps. People are. Did it build? Did it build already? Oh yeah. The switching regular Dutch. What I not use? I mean not using it, but I still need to hook it up. It just draws 200 microamps if you don't power it down. All right, that's a new file. MCU2. Did it even build the new file? Does it build the UF2? Yeah. We need to get the CPU IDs in some way. Chrome Opera. What? For? Here we go. Okay. Connect. Uh-oh. Uh-oh. This one didn't work. Oh, system volume information. Okay. Oh, wait. Oh, I have the 54 because I have the integrated flash. J, okay. Okay, here we go. But why did it, doesn't show as it's, wait, do I need to do, oh, it's a different serial project. It's like a basic serial, not CDC, is it? Yeah, this is serial, not CDC. Damn it. Okay. We need to do a different project here. Where is it? Let's check. CMake has options. For what? For that? For the serial? No. You can... Yeah, there is nothing there. Where do you see USB serial? Basil, what? You're here. Which one is it? Dev multi CDC. Yeah, that's what I think we need. Let me try the other one. Let me try arc. Oh, Pico enables STDIO USB. Yeah, but USB isn't initialized, so what's going on? Why doesn't it work? I click, nothing happens. Okay, let me close that and open it again. Somehow bugged. Yeah, but USB CDC isn't initialized. We need to initialize it first. Don't we need like the CDC project? Let's just try the CDC instead. Where is it? Multi, was it multi CDC? Multi, no. Are you sure? That is like scary, uncontrollable. Okay, let's try it. Let's try it. Let's go. Or is it? Let's build. Hello serial. Oh wait. CMake. Where do I put this again? Pico set standard set SDK Pico board cache board type SDK init init all. Yeah, but I need to change that. Pico add extra outputs. Hello serial. Where do I put the just at the end or okay. All right, let's do it. STDIO enable all. Init all does the job. Okay, let's try it with the third MCU. Ah. Okay, that's J. I can't hear a beep -oo beep. No. Didn't show up as CDC. Doesn't show up as CDC. So init all. Did I miss something? Enable STDI USB. Christian, you're the expert. While you're still thinking what the matter could be, I will just create one undefined. What is going on? It's broken. hosts. Was it multi? Nee, yeah. Doorbell. CDC multi or? Oh, there is a hello USB. Oh, this is the one. Okay, let's do it. Okay, let's try hello world. Okay, well, I don't need to care about anything here now because that will work. I hope it compiles everything. We might have just have had a build error beforehand. Does it even build automatically the? Yeah, it should. Build is just 6. Yeah, that's fresh. Yeah, we need to go to bed soon. Where's Jay? Why isn't Jay showing up? Jay, here is Jay. Okay. No, we have MCU 0, so it's E. I didn't hear a beep boop beep after it restarted. No, it doesn't look like it's an error. Yeah, it's updated. Let's see. Maybe I'm missing something. Let's reboot. Oh! There was a beep boop beep, but... Oh, yes! People... We have MCU 0, MCU 1. Oh, we can have multiple connections. MCU 2. Here we go. Yoo-hoo, it works! Okay, that's a base. Nice. Pre-order possible. Bitluni. Since I don't know. I don't know yet, but next time ray tracer. Multi-core ray 8-core ray tracer. Next time with CDC. But I mean, it's only as fast as the USB is, so we can't do much there. CMake and update platform variant. One. Okay. All that. Don't tell me. Yes. LLM. Yeah, you can run it in LLM. I won't do anything because I won't be remembering any of this next time. I hope I hope you will be remembering next time, if we do this project, what we did today. Here, this is, I show you one last time. Here. This is the thing. There are 4 more that need to be botched and I don't bother to. Which is tough. They are like 20 bucks each or 25 that I paid for. Yeah, I think I do. LLM. Low language model. Laugh out loud language model. What's the hole in the middle for? Oh yeah, that was placed by JLC. JLC assembly, the low budget assembly, they put just somewhere a hole in between. I didn't place it. I would have placed it underneath the connector, right? If you do like a panel board, then they don't need that. They just needed to like fix it in place. Probably there is a second one. Yeah, there is a second one underneath that. Here is the second one underneath the USB. So they need like two pin holes to locate it somehow. I don't know. Weird. All right, peeps. Thank you very much for joining the stream. It was a blast. We finished our Pico board, first RP2350. So with integrated flash, you can get all the schematic and board that should be working is on my GitHub. And we will play around with the IDE next time. So remember me next time that I have the IDE. Yeah, thank you, Dashipo. That I have everything installed and we just need to compile it and run it. All right, good night, everyone. Placed it now. They look at they changed scan everything anyways. Bye bye. Good night. I had also fun. A lot of fun. At some point we need to make that analog ray tracer. Bye bye. Here is Smoochie for the good nights. For you all. Good night. Mwah. Bye bye.